The next skill I want to talk about is completing the square. It's the skill most students forget that they ever learned, but it's very important. But to get there, I want to talk about sort of this special case. A lot of students are tempted to distribute this squared. What this actually means is x plus 3 times itself, the entire quantity of x plus 3 times itself. So this is sort of that special case of factoring where when you get two identical factors, you can rewrite it as x plus 3 squared. If you multiply this out in standard form, you get that 3x plus 3x in the middle and that 9 at the end. This pattern will always emerge where your factors, this is twice the factor and this is the factor squared because you're going to have two threes, right? And you're going to have 3 times itself. This is very important, and it's a very important thing to notice when you're moving on to completing the square. So completing the square is the skill that we use. This is called a perfect square trinomial. It's a trinomial because it has 3 terms, and it's a perfect square because it comes from a factor that has been squared. So consider it like if you took x plus 3 and multiplied it by x plus 3, the middle area would be a perfect square. It'd be x plus squared plus 6x plus 9. Completing the square is when we take something that's not a perfect square and we make it one so that we can get closer to that vertex form. So let's look at an example. Okay. This is an example of a quadratic that is in standard form. I want to go to vertex form because let's say I want to find the maximum or the minimum of the function, that vertex. That can be really important. In the real world scenarios, the biggest things we find are projectiles and then also profit margins. These are really big in profit margins. So the max min is an important component of that. So when I do this, and this is always like, students think this is like magical. I'm gonna look at the x squared plus 8x, and I'm gonna make that a perfect square trinomial. But I also have this plus 4 out here. And I can't just, I want this to be a perfect square, so I need to insert something here. But the problem is that will mess up the value of the function. So whatever I insert here, I'm also gonna take away to keep it balanced, okay? To keep it the same value that it started with. So to get this to be a perfect square trinomial, that perfect square that's gonna factor into a factor twice, I need to look at this relationship between these values and the factors. What it needs to be is the factor needs to be half of this middle term, right? And so we know we're going to end up with sort of that x plus 4 times x plus 4 squared, but what does that make this? So let's remember that this is always going to be that factor number squared. So this is going to be 16. Okay. The formula for that students use, and actually students end up feeling afraid of this, but then they like it better than factoring because it's sort of formulaic. This is actually, you can find this by doing 1/2 of b and squaring it. And when I say b, I do mean this middle term here. 1/2 of b squared is 16. So we've added 16. 1/2 of b is 4. 4 squared is 16. But I can't just add 16 to an equation and not change its value. So what I'm also going to do is subtract 16 out here. Really what we've done is we've added 0 to the equation, which doesn't impact it at all, but it gives us this sort of structure that we're looking for. And then this ends up balancing it back out. This is sort of like, this is how we're accounting for the fact that we've changed the structure. So positive 4 minus 16 is negative 12. I had to think for too long for that. So that negative 12, it was positive 4, now it's negative 12. That accounts for that 16 that we sort of snuck in there. And it balances it out. What we are left with is a function that's in that vertex form that we're looking for. So if we were to find the vertex of this, it would be negative 4. Remember, it's the opposite of that middle term, comma, negative 12. You'll see it written a lot like this. This is the general form. Okay, this is what the general form is in textbooks. A times x minus h squared plus k, where h, comma, k is our vertex. Notice it's minus h, so that's why we get that opposite situation happening. This was plus 4, so that's going to be the opposite. That's sort of how you get to vertex form. If you wanted to take it back out and double check it, you could. All you have to do is expand this, right? So you take x plus 4 and multiply it by itself. When you do that, you do this little idea of double distribution. You get x squared plus 4x plus 16 minus 12. And then when we combine like terms, 4x and 4x gives us that 8x that we started with. Positive 16 minus 12 gives us that 4. It is a good way to double check that once you've completed the square, you've gotten that same function that you started with.